finished the note sheets from yesterday, and most likely y'all are going to have more than enough time to finish up the assignment today. Now, kind of the equations we went over yesterday is our y equals a times x minus h squared plus k. And this is our vertex form. And we know that because the vertex is our h comma k, and our axis of symmetry is our x is equal to h. The other equation we had was our one in standard form, which tells us that the vertex is the point negative b over 2a, comma, f of negative b over 2a. And the axis of symmetry is x is equal to, and this is what we went over yesterday. Now what we're going to pick up with today is this here, and it's our x-intercept form. And we call it this because these here will really give us what the x-intercepts are, where it crosses the x-axis. And we're going to write our x-intercepts in this form here, p comma q, or p comma 0 and q comma 0, because it's going to be a point. We're going to have to give it in that form. If you just give me p and q values, I'm going to have to mark that wrong. You got it partially right, but again, intersects are a point. Where it intersect is a point, not just those specific ones. And the axis of symmetry is given to us by the equation x is equal to p plus q over 2. And it works out that the vertex is the point p plus q over 2, comma, f of p plus q over 2. Because again, the axis of symmetry goes through the vertex. And then just like we did with standard form yesterday, we plug whatever that value is back in. Questions on this so far? I'd definitely make sure you do have the vertex written down because it's not listed on the notes. Okay. So we want to find the x-intercepts, the vertex, and the axis of symmetry. Now the general equation comes in the form of a times x minus p times x minus q. And our x-intercept is going to be 2 points. And it's going to come in the form of p comma 0 and q comma 0. So what's the value of p? Almost. -3, because it's plus inside the parentheses. And the other value is going to be 0. What's the value of q? And it would be positive because it is negative inside the parentheses. And we would also have questions on this here so far. Now the other one we have is our axis of symmetry, which is our x is equal to, well, according to the formula, it's equal to p plus q over 2. That's what we need to find. We also are finding the vertex, which is our point, and it would be p plus q over 2 comma f of p plus q over 2. So the real thing we need to find at this point is what? P plus q over 2. So what's p and q? We just add them together. So negative 3 plus 1 is negative 2 over 2, which is, so the x value of the vertex is the axis of symmetry. We get x equals negative 1. Now we plug negative 1 back into the formula. So we get negative 2 times negative 1 plus 3 times negative 1 minus 1. And at this point here, again, just like with our p plus q over 2, we can type this all in the calculator, let it do it, and we'd be done. Negative 2. Well, negative 1 plus 3 is 2. Negative 1 minus 1 is negative 2. Well, negative 2 times 2 is, times negative 2 is, that's it. That's all we have to do for this here. Any questions on any of this here? You ready to look at this one here? Now the x-intercepts are 2 points, yes? Well, it's going to be p comma 0 and q comma 0, yes? So I know one point in particular is going to be, the y value is going to be 0 on both of these here, yes? So no matter what we do, we can at least get it halfway right. What can we do next? Find p and q, yes? Could p be negative 2? Really doesn't matter. We just need to pick one, and then the other will be the other one. Because the only thing we couldn't do for this problem is say that p and q are both 4, because it's not. Now, it could be, because if we had x minus 4 and x minus 4, then it would be 4 and 4. Because if both of these were minus 4, then it would be the same. But we don't have that. So we have this here. So, I mean, we could have this here, yes? But like you're saying, it would be kind of vertex form. Because really, what is this here? X minus 4 is being multiplied by its. So I could actually rewrite this as negative 1/3 times x minus 4 what? Which would mean the vertex is the point 4, 0. Well, here are the x-intercepts. If we dealt with it in this way, 4, negative 0, and 4, 0. And the vertex would be our p plus q. 4 plus 4 over 8 over 2, which is 4. So the value of the vertex is 4. If we plug it back in, negative 1/3 of 4 minus 4 times 4 minus 4. Negative 1/3 times 0 times, which we get here. So it still works, but it ends up being that the vertex and the axis of symmetry. So the axis of symmetry would be x equals 4, but the vertex and the x-intercepts are the same. Does that make sense? So here we need to find the vertex. Yes. Yes. Which is 2 over 2, which becomes x is equal to 1, yes? Now what do we need to do next? Plug it into the function, and I think they're going to be nice. Negative 1/3 of 1 minus 4 times 1 plus 2. Well, 1 minus 4 is, 1 plus 2 is, they're nice. Because negative 1/3 times negative 3, well, the negative and negative make a 1/3 times 3, 1. Because it'd be 3 over 3, which divides and simplifies to 1. And 1 times 3 is and that's it. Questions on any of this here? Be ready for the next one. And again, we're referring back to our general forms for this here. And it's in the form of y equals a times x minus p times x minus q. And the first thing we want to find is the x-intercepts. And the x-intercepts are going to be the 2 points where it crosses the x-axis. And they're going to come in the form of p comma 0 and q comma 0. And again, we get our p and q from these here. So since we have plus 1 in one of the parentheses, it's going to come out as negative 1. And it really doesn't matter if we define it as p or q. We just have to pick one of them and set it as it, comma 0. Then the other one is going to be negative 5, because since we have plus 5, come out as negative 5. And that would be it there. Any questions on the x-intercepts? Now the next part we're going to find is the vertex. Well, the vertex is given to us by our p plus q over 2, comma, f of p plus q over 2. And our axis of symmetry, it's x is equal to our p plus q over 2. So really what we need to find is our p plus q over 2, because once we can find it, we can find the rest. Well, the values of p and q in this case are negative 1 plus negative 5, or negative 1 minus 5, which is negative 6 over 2. Yes. So if we plug it back in, we'd have negative 3 plus 1 times negative 3 plus 5, which would be negative 2 times 2. Well, negative 2 times 2 is going to be, and negative 4 is just yep. 3. Yeah, times 2. Yeah. But those two are still being multiplied. And I'd be careful, and when you do that, that's fine if you apply it only to one of those two sets of parentheses. You can't apply the negative to both. Does that make sense? Yep. But that's it. Any other questions on any of this here? I'm going to let y'all use the rest of the time to work on these assignments, this assignment here. So on page 75, you're doing 3 through 9 odd, just the odd ones on 3 through 9. Then you're doing 15 through 18 all. And again, on 15 through 18, you're just matching the graph to the corresponding equation. It gives you an equation and it has 4 graphs below it. You're just matching it up. And I would use the axis of symmetry to find which one works with each equation. 21 through 29, well, with 3 through 9 and 21 through 29, you're finding the vertex and axis of symmetry. You're not graphing on any of these. Number 33, identify the error and fix it. And again, with this one here, it's going to be a little bit easier to state what the error is. It kind of makes a little more sense. It's a little bit easier to phrase. 53, 55, and 56, find the x-intercept, the vertex, and the axis of symmetry. You're not having to graph it, but you do need to find all 3. Questions on this here?